The demo application is an insurance website that allows customers to get instant quotes. The website captures different kinds of information about the customer. These input values are then validated by a rules engine and the score is computed. Based on the final score, a quote is generated for the customer. The application first collects the customer demographic information. And I'm going to intentionally enter an invalid city. And also an incorrect state. So the zip code is actually in California, but the user has entered Alabama as the state. As we submit the form data, we see the server has applied rules. It has validated the input fields and has come up with a score. So here we see all the rules that were fired. So we see that all the inputs were validated to be not null. But then the system also caught that the city and state does not match the zip code. This was done by doing a lookup based on the zip code. The system found that the correct city and state for the zip code was Beverly Hills in California. The system not only detected the invalid data, it was able to cleanse the data using the lookups and generate the score based on the cleansed data. The application collects more information about the customer, in this case the vehicle and the mileage. So we see some additional rules that are firing based on the additional data fields that was provided. So, and also the customer score has improved. And finally, the customer personal interests. We can see that with every additional bits of information, we are able to understand the customer better and provide a better score. So here we have the final score, and based on that, we are able to provide a quote to the customer. So anytime during this interaction, the application, either based on the rules results or based on the score, can tailor what set of questions it's going to ask next, or even decide to launch a live chat session with the customer to entice them with offers. In each page, you saw the list of rules that were fired for a given data set. We can store this information and mine it, and this is really powerful. This allows the application and rule developers to go back and optimize and enhance the rules to improve the business logic. They can then deploy these updated rules, replay the captured data set, and evaluate if the new rules have improved the outcome. And this stored information can also be used in machine learning and automate some of the rule improvements. Now let's look at the rules used in the demo. So we used the Java dialect for the rules engine, and this is the DRL file. So at the top you see two import statements. So these are Java objects that are fed to the rules engine. A message is a Java object that contains all the input elements from the web form. So you see the different rules. So this is validating the first name, last name, city, and so on. And you also see this method called increment point. So based on the rule validation, we can add or decrement points. So this becomes the final score. And you also see this method called get fired rules. So this is how we actually propagate the list of rules that were fired back to the calling application. The rules info helper is the object that collects all the rules that were fired and the tuples that were fired. And you can see here there's several rules, so you can have multiple rules on the same set of fields, and based on your conditions you can increment or decrement points to the overall score. So if the customer resides in certain specific cities, you can choose to improve their score, or if they're living in cities which is high accident prone, then you can decrease the score.